Hello, this is Professor Teresa Pelkie. This is Session 11, Part 1, Concepts of Views. In this session, we will look at another type of object that you can use in a database. That object type is called a view. In this video, we'll go over some of the concepts of views. You'll see why you would create views and how they make it easier to work with your data. In Part 2, we'll go over the steps that you'll use to create, work with, and maintain views in a database. To get started, let's review this join that was shown in the previous session. This join is in the college database. It is used to get a list of students who have an advisor and who have been awarded a scholarship. As you can see, this is a moderately complicated select statement. There are two concat functions used in the column list to create the full student and advisor names. We've also assigned alias names to the results of the concat functions. The join statements are not complicated. Recall that when you use just the keyword join by itself, the type of join that is performed is the inner join. An inner join means that you will only see data in the result grid if you have matching data in both tables that are in the join. The problem with this join is not the actual statement itself. As you can see, this is not a complicated statement. The problem with developing this statement is that you need to be very familiar with how the tables are designed in order to create the correct join. Keep these points in mind. I'll come back to these issues in a few minutes when I talk about why you define and use views. Now here's an example of using a view. You can see that now we have an extremely simple select statement, selecting all of the columns from what appears to be one table. In this case, the from clause uses a view named students_scholarships. It takes the place of a table name. This view returns the same data that you saw on the previous slide. So rather than have the column list with the two concat functions and the three join clauses, you now have this simple select statement. As you'll see, there's no magic here. Behind the scenes, we have created a view named students_scholarships. That view is made up of the select statement that we saw on the previous slide. Once you create the view, it remains in the database. It is not a table since it does not contain any data. Instead, a view lets you access data in the underlying tables. So what is a view? A view is a select statement that has been saved in the database. It is saved by running a create view statement, which you'll see in the next video. The select statement can be any valid combination of tables. You can have one or more tables. If you have more than one table, you can use any of the join types that we learned about. You can specify the column list. The list can contain the simple column names from the underlying tables, or it can contain derived columns. A derived column is a column that is the result of running a function or performing a calculation. For example, you saw that we used a concat function to create the full student and advisor name, and then we assigned an alias to the function result. That alias is the derived column. A view can contain almost all of the clauses that are used with select statements, including from, join, where, group by, and having. Notice that the order by clause is not in this list of clauses. Because a view does not contain data, it does not make sense to specify an order by clause. Instead, you can specify an order by clause in the select statement where you use the view, as you saw on the previous slide. Why would you use a view? The primary reason is so you can encapsulate commonly used or difficult to work with select statements into an easier to use object. One of the big uses of views is with end user query tools. In many organizations, If you are the person who is considered to be the go-to person for all things related to the database, you will be working with users in addition to developing SQL for applications. For example, many users use applications like Excel or Microsoft Access to work with data. They will often need to get data from the main database, which might be under your control. Now, many of the tools that an end user might work with have graphical query generators built into the tool. Using those generators, the theory is that the user can drag and drop table definitions, creating joins without writing any code. The generator is supposed to create a valid select statement to get the data. Now think back to the example I showed you earlier in this video of the students who have an advisor and have been awarded a scholarship. To create that select statement, you need to know how the college database is designed and how the tables are related. Compare what you need to know about the database and the knowledge you need about SQL to develop what is relatively a simple query. In most organizations, you would not expect the users to have that in-depth knowledge of the database and of SQL. Even with a generator tool, it can still be difficult to correctly specify a multi-table join and get the correct results. But users still need to get the data. As the database person, you can make your job easier and help the users by giving them a view. That way, they can run a simple query against what appears to be a single table, as you saw earlier in this video. This is one of the big uses of views. To create effective views for users, you will need to become familiar with their requirements and figure out how they refer to the data they are working with. Rather than try to make them learn about how the database is structured, your job is to find out what they need, then create views as adapters that give them access to the data in a way that makes sense to them. Another big use of views has to do with security. If you allow end users to directly access your database, for example by using a query tool, they can potentially access all of the data in tables they are authorized to. Since many databases are not configured very well as far as security is concerned, you may have a huge security exposure by letting users have unrestricted access to the database. If you create views, you can limit a user so that they can work with the views, but they cannot directly work with the underlying tables. For example, let's say you have an employee table that contains sensitive data like Social Security number, pay rate, and other data that has privacy issues. You might have two types of users in your organization who need access to the employee table: human resource users and payroll users. The HR users do not necessarily need to see the Social Security numbers or pay rate. So rather than let them run a query directly against the employee table, you can give them a view that omits those columns from the view. If they are only allowed to work with the view, then they will not be allowed to look at the sensitive data. Some other reasons to use a view rather than a select statement are shown here. You've already seen some of these examples used with the select statements shown earlier in this video. You can also use a view to assign column names using the alias keyword. Now, since you can use an alias on a normal select, what is different about using this with a view? The difference is, once you define the view with the alias definitions, those definitions are set. Rather than having to specify an alias over and over again each time the table is used, you can define the alias values that you want to use in the view. The same concept applies to calculated or derived columns. This example shows a concat function to create a student name column made up of the first name, a space, and the last name. Rather than have to specify the concat function over and over again, you can put this into a view and have it defined once and for all. A final example is to format data. You saw this calculation earlier in this course where we calculated the population density for a country. This format function formats the result of the division as a decimal value with 2 digits to the right of the decimal point. You can specify this function once in a view and have it available for future queries. Again, there is no magic with using a view. It is true that you can profitably define and use views for all of the reasons shown on this and the previous slide. The issue is you need to put some thought into how you will use the view. Developing the view is trivial since it amounts to simply developing the select statement that gets the result that you need. But before you use the select statement to create a view, you need to do some role-playing and think about how the view will be used. For example, if you have a concat function to format a name with the first name, space, and then last name, what will happen if the application needs a name that is formatted as last name, then the first name? It may be the case that you should include both formats of the name in the view. Once you've defined a view, you can use column functions and all of the other clauses with the view. For example, you can use a where clause with a view. So you might need to consider, should you put the where clause in the select statement that you use to create the view? If you put the where clause in the select statement used for the definition, then the view will provide only a subset of the data in the underlying table. In some cases, that will be exactly what you want to do, but in other cases, you might want to not limit the data. The user can specify a where clause when they select from the view. All of this is just to say that views are easy to create and easy to use, but you need to plan the data that is to be provided through the view. In the next video, we'll look at how to create, work with, and maintain a view.